Today we'll be covering lesson 3.5, solving systems using matrices. And one of the things I've been telling you is as we do these Gaussian elimination problems, that we do them in a very methodical way because it's a way that we can program a computer or a calculator to be able to solve them for you. Well, what I haven't told you is that all of your calculators are capable of solving systems of equations. As long as you input them as matrices, your calculator can solve 2 and 3 variable systems of equations that we've been solving in class by hand. Now, I wait to tell you this because I need you to do them by hand first, and I will expect you to do them by hand, especially on quizzes and tests. But not all of the problems have to be done by hand, and I certainly need you to know how to use matrices for more complex problems and also to check your work. So just like we've been doing all along, I have a system of 2 equations right here, and we are going to write what we're calling an augmented matrix. This is what we've been writing as we do Gaussian elimination problems. We just haven't named it yet. And so we end up with the first equation in row 1, the second equation in row 2, and we're only writing all of the coefficients of the variables. This line right here is an understood equal sign that actually isn't part of my matrix. It's just an understood equal sign. So we end up with a matrix that has 2 rows and 1 column, 2 column, 3 columns. And remember, all of this column are x's, all of this column are y's, and everything in this column are your constants. So we end up in matrix form as we've been using, only now when we put them in our calculator, we need to pay attention to how many rows and how many columns there are. So this is a 2-row, 3-column matrix, so we consider it a 2 by 3. All of our matrices are named in terms of the number of rows and the number of columns they have. So what we're going to look at is putting these in our calculator, and in your notes, if you'll follow along, I've included all of the keystrokes. So you have that as a reference. So if you'll work the problems with me, you can go back to your notes as a reference on all of the keystrokes. So here's our very first example. We have a 3-variable system of equations. We are going to input this in matrix form. So 5, 3, 2z equals 2, 2x, 1y, negative 1z is 5, 1x, positive 4y, 2z is 16. Now what you've been doing is taking your matrices to row echelon form, and then you've been using back substitution to solve. Your calculator will do that as well, but your calculator will actually go a step further for you. So if you will go to your graphing calculator and go ahead and reset it, second plus, and then follow the commands for reset, all RAM, and it'll ask you if you really want to reset. So if you look at your calculator, your matrix button is over on the left side of your calculator, and it's the x to the negative 1 button. So it's the second x to the negative 1 button, or we use our second key to get to anything that's in another color. Oops. All right, so we're going to go to second and that x inverse, and we are going to first edit a matrix. We have to put it in. So we're going to toggle over to edit, and we're going to pick the first one, matrix A. So we can go ahead and select that. We have 3 rows, and we had 1, 2, 3, 4 columns in our example that we just wrote. So if we enter 3 by 4 and we hit the enter sign, our calculator will take us into all of our entry points. So what's highlighted right now is the first row, the first column, which was 5. And then we can hit enter, and it will take us all through row 1 so that we can enter the equation. Remember, the sign in front of the number goes with it. So a negative 1, you have to use the negative sign down near enter and the decimal place at the bottom. It's the negative sign. And 2 and 16. All right, now once our calculator is in matrix form, it kind of gets stuck here, so we have to quit. So we go second mode to quit. And we're going to ask our calculator to go back to matrix mode. So we're going to go to second matrix again. Now we'd like to do some math on the matrix C that we have. And notice on number 1 it has 3 by 4. So we're going to go over to math, and we are going to have all of these choices, different things you could do with your matrices, and we're going to go to first row echelon form, REF. And if we hit enter, it's going to ask us which matrix. So we have to, again, go back to matrix to select it. So second x inverse go to matrix, and we want to select matrix A, and then we can hit enter, and our calculator will take us to row echelon form, which is what you've been doing all along, and you can arrow over and kind of see what your row echelon form would have been. And it's still somewhat messy, and you have decimals, and you have to go back and do back substitution. Well, the beauty of doing matrices on your calculator is it'll do even more work than we've been doing. You can get to what's called reduced row echelon form. And so your goal is to take this augmented matrix to reduced row echelon form, or on your calculator, that's RREF, and it will make your calculator solve the entire matrix. So if we go back here again and we go to matrix, we select math, we can toggle or arrow down until you see RREF for reduced row echelon form. And so on my calculator, it's going to be choice B. And then we're going to go back to matrix, and we're going to select matrix A, and our calculator will put the matrix in reduced row echelon form. And so what this means is we have 1x, let's go back so I can write this. So what this means is we have 1x, no y's, no z's is equal to negative 2. And we have no x, 1y, no z is equal to 6. And no x, no y, plus 1z is equal to negative 3. Or if we wanted to simplify this, this first equation is just an x and nothing else, so x equals negative 2. The second equation was just y and nothing else, so y equals 6. And the third equation was just z and nothing else, so z equals negative 3. So my triple, my answer is x, y, and z. Negative 2, 6, and negative 3. So if you know how to do matrices on your calculator, they can save you a lot of time, but they can also be a great way to double check the work you've been doing. So let's look at another couple of examples. We can enter 2 variable systems in our calculator. You can enter 3 variable systems in your calculator. You can even enter decimals in your calculator. So if you want to take a look at this one, let's input this in our calculator. Oh, and you can even input fractions in your calculator as well. So if we go to our calculator, we're going to input a new matrix. So we're going to go back to matrix. We're going to edit matrix 1. And this particular example has 2 rows and 3 columns. And so we have 0.5x, 0.7 for y, and our constant is 5.5. In the next row, we have a 3, negative 2.5, and negative 0.5. And so if you hit enter on that last one, it'll actually input it. We have to quit. We're going to go back to matrix. We are going to do some math on our matrix. So we're going to go down till we find reduced row echelon form. So reduced row echelon form, this was matrix A. So if we go back, we select matrix A, and our calculator will do the reduced row echelon operation. So x is equal to 4, and y is equal to 5, or we have the point 4, 5. So reduced row echelon form will certainly save us a lot of time and a little bit of heartache. We can even do this with word problems, but we must first write them in a matrix form. So this says the sum of 3 numbers is 6, so that would be x plus y plus z is 6. The third number, so we'll call that z, is the sum of the first and second numbers, the sum of x and y. The first number, so we'll call that x, is 1 more than the third number, z. So there are our system of equations. If we're going to solve using matrices, we've got to put all of them in the same order. So all of our x's in one column, all of our y's, all of our z's, all of our constants in our augmented matrix. So 1, 1, 1, 6. We will have to rearrange this second equation. So we could write this as x plus y minus z is 0. So 1, 1, negative 1, 0. You could also write that as negative 1, 1, 1, 0, depending on which side of the equal side you've put everything on. For this equation, we can have x minus z is 1. So 1x, no y's, and negative 1z is equal to 1. So if you'll take a moment to put that in your calculator. All right, so on our calculator, we're going to input this as a matrix. we're going to, I always, oops, let's go back, sorry about that. I always edit just matrix A so I don't have to remember what the name of my matrix is. So I have a 3 by 4 matrix. My first equation my second equation, my third equation, I'm going to quit, go back to matrix, I'm going to do some math, I'm going to select reduced row echelon form. Oh, and my calculator froze. So when I solve this on my calculator, I get that x is 4, y is -1, and z is 3. So there is our solution to our system of matrices. Now, for today, you got lucky in that I am home with sick children, so you do not have your Gaussian elimination quiz today, but we will have it next class, which is your review day for the test. So I do expect you to be able to do a word problem or a Gaussian elimination problem by hand without using your matrices. And I'm going to check all of your steps, so I'm going to need to see each step. So please be very careful. Don't use only matrices. You have your review for your test. Your review is due on the day of your test, but you're going to want to get as much of this done as you can today and tomorrow so that you can get help before your test. Your test is next week on Monday for you guys. Your quiz is next class. Before you leave today, make sure that you turn in homework 3.4. You can use your calculator to check, but I have to have all of your work turned in with your homework 3.4. So homework before you leave. Once you're done with that, start working on your review and preparing for your quiz, and I will see you next class. If you need any help, I will be here tomorrow. You can always see one of the other teachers listed on the pink sign on the inside of the classroom door. Have a good day, guys.